I would say definitely take it upon yourself to learn. And this could be a good first step. I think I heard some people talking about industrial engineering in there. You can use it for your optimization courses, you know. You can use it to, anytime you're finding difficulty in Excel, there's a good chance VBA can automate that for you. And today we're going to cover a lot of the tools that will be useful for that. We're going to go over this once we actually move over to Excel VBA. This is how you're going to install the developer tab. Some general coding ideas. You should always add comments as the larger your code grows. And in VBA, you comment by putting that apostrophe. Putting comments there makes it easier for you to follow and for other people to follow as long as tabbing your code. And then those are 3 ways to make your code just run faster for solution times. You can declare a bunch of different variables. And in VBA, you say dim, which is dimensioning, variable name, as, and then you say what type of variable it is, whether it be integer, double, long, string. 2 types of arrays. Arrays, generally you're going to find that a lot of more complex problems are going to need an array. And so you're going to want to use a static array or a dynamic array. The trade-off is if it's going to be the same process every time, a static array is going to be good since you know I'm only going to be dealing with 20 variables. The dynamic array is better when that number of variables may grow. And while the code is running, it will evaluate the need for another indice in that vector. And we're going to cover a dynamic array today. 3 loops we'll be talking about are the for loop, the while loop, and the do while. The for loop is very good when you know I'm going to be executing this code 10 times. The while loop is very good when you have a stopping criteria rather than a stopping number. So when x is greater than 5, that's when I want this loop to end. And then do while is great. Let's say you want to execute a loop. It's not guaranteed with a while that it will enter the loop the first time. A do while can ensure that the code will at least execute 1 time. And also, I'll take a moment to slow down here. If at any time I'm going too fast, feel free to interrupt me and say like, hey, why is that? Especially when we get into VBA. So just basic syntax for a for loop and a while loop. For I equals to 1, 2, 100, just a random functions inside both loops, and then next I and wn. For the for loop, you can also have a step function. This is default, steps I by 1, so I will go from 1 to 2 to 3. If we added for I equals 1 to 100, and then step 2, now I will increment by 2. If that makes sense. And you can also increment negatively, so you can say for I equals to 100 to 1, step -1, for instance. Here's the do and the do while. So the big difference here is you can see on the do loop, it's going to execute. There's no constraints for it to enter that loop, but once it gets down to the bottom, it'll say while x is less than 2. Versus here, if x is greater than 2, it won't enter the while loop once. Also useful is the if statement. These are block ifs, meaning block if is just when you say if, then, and then you tab down so you can put a bunch of lines of code inside. This is just an example of something you could do. And inside these blocks, you have a message box. You say, okay, x is in between 2 and 0. And the input box is great. So if you're, for example, when I was using this at my internships, there were things that the users would need. Like, today demand is 100. And so you could say, you have an input box every time they run the code and say, what is demand for today? They enter 100, and that helps drive the code. Message box is kind of at the end. It'll say, okay, demand is 100. We're able to produce only 90 today. And then user form is another good thing. I did that for a row node. And that kind of makes it like a real user interface. We're not going to cover that today, but we will cover input box and message box. And most importantly, I think even myself, you're never going to code it maybe right the first time. So you should get real used to debugging. Adding a watch allows you to see the value of your variables as you step into your code. And you step into your code line by line to see how each line is affecting everything. And a breakpoint is if you know at a certain point in your code something's going wrong, instead of stepping into it, you can just run your code, break at that spot, and now you can see what's happening. So it's like a fast forward button basically. And then functions. Again, we're not going to cover functions today, but very useful when your code grows larger. So if you have a calculation that requires 10 lines of code, and throughout your code, you're going to be executing that 10 times, that's 100 lines of code. Function will allow you to define a function similar to here, write those 10 lines of code, and then later on in your main subroutine, call that function 10 times. So you reduce your code from 100 lines of code to 20 lines of code. If that makes sense. So it's useful when you're really growing your code. And then lastly, when you're doing maybe a less mathematical and more superficial thing, which your clients, whoever you're working for will definitely want, it's good to record your macro, and you'll learn things that through VBA that you wouldn't know exist. And we're also going to go through recording the macro. All right, so now to VBA. We're going to see how to install it on a Mac and then a PC. So to install the developer, so you need the developer tab. I don't know if you guys have that. If you don't, that's okay. For the Mac, you just go for Excel, Preferences, go here to the ribbon, scroll down and make sure the developer is clicked. Does everyone with a Mac have that down? I don't hear, no. Let's see down. And then for a PC, you go to File, Options, Customize Ribbon, and the same thing, make sure that developer tab is checked off. Now we've got that. We're going to jump into VBA. Alright, so now we have our first code, and I have an example that we're going to do. So what this is saying is, when you list out the first 6 prime numbers, the 6 prime number is 13. They want to know what is the 10,001st prime number. This is more of like a typical computer science problem, and this is a good way for us to learn some of the basics for coding. So we'll put in our first comment and say, what is the first, what is the 10,000 first prime number? And so, since we don't know how many iterations we're going to go through, and we know there's going to be 10,001 prime numbers, that's when we'll stop. This is a good chance for us to use a while loop. And first, we have to dimension our count variable. So we'll say dimension count as long. So this count variable is going to count how many prime numbers we've found so far. And we'll have our while loop, and we say while count is less than 10,001. Put a WN down here. So we'll talk about this conceptually. The way we're going to have this iterate is, you want to know the 10,001st prime number, so this while loop is important to make sure we're incrementing correctly. We're going to have count enter here. At the end of, it's going to find the 10,000th prime number, and this loop. Increment count to 10,000. It's going to be up in here with 10,000 prime numbers, searching for the 10,001st. Once it finds it, it'll be at 10,001. The next time it comes to the bottom of the loop, it comes and check, and now count is equal to 10,001, therefore the loop is over, and we'll be sure that we're actually printing out the 10,001st prime number rather than the 10,002nd. So what else do we need? We need a variable for the number we're about to test if it's a prime number, and we'll say as long. And so I could use an integer here or a double. I'm going to use a long, just use long, it allows you to store more memory. And we're going to be getting to pretty high numbers, so long it's more reliable in the fact that we won't get an overflow error. So let's think about this. We know while count. And we're also going to need the number we're dividing by. So we'll say dim I as long as well. So now I think we can enter the while loop, and we're going to say if number mod I is equal to 0, then we're going to leave this blank for now. But what this is saying is what the mod operator says is when I take number and I divide it by I, if it evenly divides into it, it will result in 0. That would mean it's not a prime number. So for instance, 3 mod 2 will result in a remainder of 1. There's 1 left over in there. And that's how you would know 3 is not divisible by 2 evenly. And so what we have to, we're going to have to, there's a couple different ways we can do this. To enter this, we say for I equal to 1, 2, number, increment, sorry, I'm just coding this on the flies. Next I. And so, probably can't make this too interactive, but the reason why first look this may not work, if we go from I equal to 1 to number, not only is that going to be a heavy amount of iterations by the time we get to the 10,000th prime number, it's also 1 and number are divisible by, the number is divisible by 1 and itself, so that might not be a good idea. So we should start off at 2, and maybe we should end at number minus 1. But again, I think, and I'm just trying to maybe talk with you the idea of how we can code this more efficiently. Now, if we do this iteration, and we're going to be testing out that number every time, starting at 2 and going to number minus 1, maybe we know once we stop at number divided by 2, we're at half the number. Once you go past that, no number is divisible. It can't be divisible by anything evenly after that. So maybe we can cut this I loop in half. Or we can also say we can increment that number. We don't have to check any even numbers, for instance. So we know 4, 6, 8 aren't prime numbers. So we can start number off. We can start number off equal to 1, let's say. And every time we increment number, we'll say number is equal to number plus 2. The reason why that's beneficial is that now we're no longer checking any even number. So it's going to check 1, 3, 5, 7, 9, 11. What we should do is, so we know 2 and 3 are prime numbers, and we're going to start off with the initial. We're just going to say count equals to 2, number equals to 4. If we know 2 and 3 are primes, we're going to have to maybe put in some extra if statements if we put that in there. So let me think. Number 3 minus 1. So okay. So actually, I'm sorry, but we should keep this as a while loop. Because although we shouldn't go to number less than 2, it'll be a little more dynamic if we keep it as another constraint rather than a stopping point. So we'll say while count, while I is less than or equal to number plus 1 divided by 2. So now we're only going to be checking, we won't be checking any even numbers when we're dividing, since there's no point in doing that. Let me make sure. So we have to do like a mental check to make sure we have the correct starting point for this. But count equals 2, since we already know 2 and 3 are prime, number equals to 4. So when we enter this first loop, we're going to say while count is less than 10,001, while I is less than number plus 1 divided by 2. So in this case, it's going to be 4 divided by 2. So 2. It's going to come right through this. It's never going to enter this loop, but that's okay since we know it's prime. I think we're also going to have to create a pool, like a check, to say is this number prime or is it not prime. So we'll say dim test as pool. And we're going to assume, we're going to say it is Boolean until it's proven that it's not Boolean. So true. Come down to here. 2. if number is divisible, then we're going to want to increment number is equal to number plus 2, and we're going to want to exit do while. Exit do. Okay, so let's take a quick break just to talk about what we have here so far. Does anyone have any questions for me before I try and talk through this with y'all? Okay, so I've declared count as a long to keep track of how many prime numbers we've encountered. I've declared number as a number we're going to be checking to see if it is prime. I've declared I as a long, and that's the number we're going to be dividing into the prime number. We're assuming we know 2 and 3 are prime, so count is equal to 2. We're creating a test to see if it's bool. We're setting test equal to true. So number equal to 3 is going to enter the loop and say while I, currently I is not assigned, so we're going to have to work on that. Number equal to 1 plus 2. So number is 3, 4, 2. So that would be 2. And we're going to have I equal to 3 at first. Since we're not actually worrying about any even numbers, we can set I is equal to 3. This is okay because we know, again, we're going to know 5 is prime. It's going to not enter this loop. Come down here to where we're going to loop, not do. And then we're going to say if test is equal to true. So we have another if statement. And if. Sorry I'm bouncing around a lot here, but we also want to say test equal to false, since we know it's not a prime number. And so if test equal to true, then number is equal to number plus 2. Also we want count plus 1. So we're getting close to being able to execute this code, but let's think about this. I actually think it might be more efficient, instead of incrementing here, if we put it up here at the very top. We also do this. And so what that's going to do is, and also we want to make sure that inside this loop, every time test is true. So let's think about this and make sure it's going to work. So we're saying we know 2 and 3 are the first 2 prime numbers. So we have number set equal to 3, so that's where we left off. I equal to 3, it's going to enter this while loop, count is set to 2. It sets test equal to true. It says number is equal to number plus 2, so our number is equal to 5, our I is equal to 3. Number plus 1, we have 5 plus 1 is equal to 6, divided by 2 equals to 3. So we have I less than 3, that's not, I is equal to 3, not less than 3, so it's going to skip this loop. It's going to come down here, test is equal to true, count is equal to count plus 1, and if Wn, come back up here, test is equal to true by default, and it's going to test now the number 7. So that's the first iteration. We can step through this now, but I think this is going to execute correctly. Does anyone have any questions as to why maybe I did some of this stuff? I bounced around a lot, so. No questions? Okay. So if you follow along, you say debug, go to add watch. We're going to add count. We are going to add number. We're going to add I. We should also add test. Okay. So the step into function is, for me, it's Command-Shift-I. For a PC, it's going to be different. So maybe if you press this debug and come down here, you can see what step into is. max command shift I, we're going to step into it. It initializes all the variables. It says count equal to 2, I equal to 3. We're going to come in here. Test equal to true. Number is now equal to 5. Should not enter this do loop. Test is still equal to true. We have our third prime number. Number is now equal to 7. 7 we also should know is a prime number. We're going to step through and see how it executes again here. So I is equal to, okay, what? Okay, so we found our first debugging mistake. We have to reinitialize I equal to 3 at the beginning of every loop. And that might be it. So we're still okay to keep going, actually, since I didn't get incremented last time. But it should not be mod by I. And if loop. Okay, we found one more error. That's okay because it's pretty big. But in this while loop, we need to increment I. So at the end of this, we should say I is equal to I plus 2. Now I think we have something good. Definitely. So we'll reset the code and step into it one more time. I equal to 3, count, test equal to true, numbers equal to number plus 2, I equal to 3. So we're going to enter this loop, we should skip over the do loop, enter 5 as a prime number, which it does, count increments to 3. Come back up, number is equal to 7 now, I equal to 3. It comes in and it says I, as long as I is less than the number to 7, increment that to 8 divided by 4. So as long as it's less than 4, keep testing. So it's going to enter this loop once to test it. It increments by 2. It's no longer less than. And again, we have our next prime number. So we have our first 4 prime numbers, 2, 3, 5, and 7. I think at this point we can run our code. So at the very bottom, we're going to say MSG box. So what this is going to do is after we run this code, it's going to give us our prime number, the 10,001st prime number. Might take a second to solve. We have the solution here. And we're looking for 104,743. Almost 104,743. So that is one way to do it. There's a more efficient way that HD actually found. Does anyone have any questions? I think we're going to go into the more efficient way because it'll show how to do a dynamic array.
How did you pull up that window that has the watches on it?
Sorry, the what?
The watches. That
Oh yeah. So I went add watch. You type it in, like type in, and then it should pop up for you. If it doesn't pop, is it not popping up?
No, I just.
Yeah, okay, sorry about that. Does anyone have any questions before we move on to the next part of this code? I think it might be a lot to handle, I'm not sure, so feedback would be good. Okay, so we're going to move on to a dynamic array. We're just going to make the for loop. So I think it maybe took 5 seconds to calculate, which isn't too bad, but this is an academic problem. When you're in the real world, a problem could take a minute long, 10 minutes long. And the longer your solution becomes, the less good of an answer it is. So a lot of people are going to want to answer now. So we'll find another way to make this maybe a better solution. So we're going to do what's called a dynamic array now. And so we'll say prime number as long. So what I've done here is I declared these parentheses are initializing a vector or a matrix. In this case, it's going to be a vector, and it's undefined. But that's what you need to do in order to be able to redimension things. So what we're going to do now is we're going to say redim prime number to count. So what I've done here is it went from an undefined, in this just one line of an undefined matrix or a vector to I redimmed it to prime number count. Count is set to equal to 2. So now it has 3 indices, 0, 1, and 2. And we're going to quickly set prime number 1 equal to 2, prime number 2 equal to 3. So now using this, we are actually going to comment out a lot of this. So I'm not sure. I think we need to, I'll leave it for now. But now, since an efficient way to think about this problem is that if you divide your current number by all the current prime numbers, and it's not divisible by any of them, it is itself prime. So that's gonna reduce the number of values you're basically checking. So the second loop is going to become much, much smaller. And so I think the solution was 104,000. So I think we cut maybe that iteration into a fourth, but that's still over 25,000 values you're iterating. And when the number was 104,742, it still went through around 25,000. So it's going to add up real quick. So now we're going to say, for I equal to 1, to count, which is how many prime numbers we currently have, and we're going to say if number mod prime number I is equal to 0, then, and if, we can just take this. So, I think everything inside of this, we're going to leave it, but I'll comment it away. It's no longer useful. So what I've done here is I'm saying for I equal to 1 to count, if number mod prime number I equal to 1. And so when I is equal to 1, I'm saying prime number indices 1. That we saw up top was equal to 2. So then 2 is count is equal to 2, so when I increments by 1, 2, this value will be prime number 2, it'll be the value of 3. So it's going to check if it's divisible by either of those numbers. I believe we don't need this anymore. I'm going to leave that commented for now. And I think the only thing we have to do is if we have found a prime number, then we have to say, redim, preserve, prime number, count. So what I've done now is, every time you find a new prime number, you have to increase your count. So now we have, when we get the third prime number, now we need to increase that array to 3 indices. That's why I say redim, preserve. It's preserving all the values that are currently in that array. And then prime number count. Count now equal to 3, so you have your 3 indices. 4 if you count the 0 index. If you don't have this preserved, it'll redimension it to a 3 indices vector, but it will erase the values stored in 1 and 2. And that might be it. I'm just trying to think. the last thing we can do is just to show you all the prime numbers for I equals 1. To count next I. Which sheets do we have? Sheet 1. So this is going to be more, I guess, interfacing with Excel. So you type in cells, the row we want to print it on, which we want it to be I1 dot value is equal to prime numbers I. So what I'm saying is, sheets, sheet 1 dot select. So at the end of this code, I'm selecting sheet 1, and then I'm saying cells I, comma 1. The I is the row value, the 1 is the column value, and I'm saying the value of that cell should equal to prime numbers I. And so it's going to go from 1, 1 to 2, 1 to 3, 1 to 4, 1 and print out all the values in our dynamic array that we created. So let's step into it to see if we're on the right track. Prime numbers. And when you add the watch, you should leave the parentheses blank, so that way you'll be able to open up the entire vector. So we'll step into this. Okay. Prime number, not prime numbers. So we'll step into it. And again, count equal to 2, number equal to 3. That's equal to true, increments to 5. It's going to divide 5 by 2. And then again, it's going to divide 5 by 3. You can see. So you can see here 2 and 3. So when divided by prime number, index 1, index 2, divided by 2 and 3. Now we can safely say that it is not or it is a prime number. We increase the count, we redimension it. Now it's got 3 slots. And the one thing I didn't do is say prime number count equal to current number. And with that, I'm pretty sure we can run this. So that's the last number. Okay, so let's reset this and give it a run. So I mean, you can see, so 1 it's solved in, I guess, a second. Definitely quicker than the first time it's solved. You can see how important debugging is, you know what I mean? So I wrote it out and I had the gist of it right, but I had to step into it to make sure everything was executing the way I thought it was. Are there any questions with that? Because now we're done.
You just scroll up and show the top portion of the code.
Oh, yeah, totally. Is there any questions? If you have any, feel free to ask. We're moving on from this in a second.
Taking forever to
It's taking a while for it to solve.
put
for you.
the prime numbers in onto the column.
Oh, so yeah, so I'm sorry. Mine should be done. It's not showing up, but they're there. They just didn't show up. But they are all there for me. Any questions? Okay, we're going to go through one more CS type problem, and then we're going to go through more repetitive tasks. If you know what I mean. It might be more applicable to a lot of the things you'll be doing. Is your problem resolved there?
No, I mean it's just
Just left. Okay. So there's a thing called a palindrome. We're not going to do this particular problem, but basically, if it's spelled the same way forwards and backwards, it's a palindrome. So race car is a palindrome, for example. So this is going to deal with strings. We're creating a new subroutine called palindrome. It's going to automatically fill some of that in a sub. So we're going to say we're going to need another variable to test. We'll see. test as Boolean, which is binary, yes or no. We're going to say dim word, that's the word that we're going to test, as string. Dim word length, which is going to measure the length of the word. Integer. And I think that's all we're going to do. So the first thing we do is now we say word is equal to input box. What do that's the word. So this is going to prompt the user to say, what word do you want me to evaluate? And then from there, we need to figure out the length of that word. So word length is equal to len word. This is the functions we're actually going to use for this subroutine are identical to the ones in Excel, if you're familiar with some of those strings. So this is just going to be the length of that word. Now we have two cases. One where the word is even, and it has an even number of words in it, and one where the number is odd. So for example, race, car. The R needs to match this R. The A needs to match this A, and the C needs to match this C. That E doesn't need to match anything. Another example would be mom. The O doesn't need to match anything. I'm just going to make up a word, but who? All the words, all the letters in that word need to match each other. So now we're going to have two cases. If word length odd 2 is equal to 0, then we're going to have an else. And then we're going to have an end if. So the reason why we can do this, since we're doing an else rather than an else if, since there's only two options. If there were three options, we would have to do an if, else if, and then an else. But in this case, there's two options, so we're safe with just doing an if and an else if. So this is going to be the case where it's an even word, so there's only 8 letters, 4 letters, something like that. So we're going to have to do a for loop, say for I equal to 1, 2, word length divided by 2.